Hello, so in today's video, we're going to solve a couple of exponential equations. So we're going to solve a couple of equations where we need to find the x value, where we've got the x value within the powers, so the x value within the exponents. So if you haven't seen yesterday's video where we converted base numbers of 2, 3, 4, 5, etc. into a base number of e, I do recommend you watch that video because especially with the second equation here, we're going to need to know the content of yesterday's video in order to do that one. So please do make sure you've watched my video on converting different bases into a base of e. So do make sure that you watch that one. But with the first one there, we can actually we don't actually need that trick with this first one. So let's start with solving the first equation. So we've got 2 to the power 4 take away 3 x equals 11. How can we solve this? So remember, we've got to try and get the x. We want to get rid of this power or this base of 2. So we want to get rid of this power of 2 in the bottom there. So what's the inverse of raising a number to a base of 2? Well, it's taking the log of base 2. So remember that if your function is 2 to the power of x, then it means your inverse function is your log with a base of 2. Because yeah, that's what we looked at before, and that's how we defined our logarithm. So we're going to apply a log of base 2 to both sides. So therefore, we get log base 2 of 2 to the power 4 minus 3x is equal to log base 2 of 11. And remember, because again, as we mentioned here, log base 2 and 2 to the power of x are inverse functions. So therefore, we get rid of this exponent of a base 2. So we're just left with the power. So 4 minus 3x is equal to log base 2 of 11. So just in the same way that sine and sine inverse or inverse is just in the same way that dividing and multiplying a number inverses. Log base 2 is the inverse of raising a power to a number with a base of 2 to a power. So therefore, we just get the input into the exponential with base 2 there. So we get this there. And then it's just a case of solving this equation. So we can therefore say that 3x is equal to 4 take away log base 2 of 11 just by taking away the log base 2 and adding the 3x to both sides. And then finally, just divide by 3 to get our final answer. You will get that x is equal to 1 over 3 times by 4 take away log base 2 of 11, or 4 take away base 2 of 11. 4 take away log base 2 of 11 divided by 3. That's going to be your answer there. And obviously, yeah, you can put that in the calculator and see what you get. I've not actually got a calculator nearby me right now, but if you put that in the calculator, you'll get the x value, the exact x value for that. Well, this is the exact value there. If you get a question in the exam saying give the exact value, that would be your exact value there. But you can put, if you've got a given answer 2 decimal places or something like that, then obviously you just want to put that in your calculator. So that's the first one. Now let's solve this second one here. So you've now got 3 to the power of 2x minus 7 is equal to 4 to the power of 5 take away x. The problem with this one is that we've got different base numbers. So it's not like the previous one where we can just say, okay, well, let's take a log base 2 on both sides, and then you get rid of your base of 2 there. We can't really do that now because we've got different base numbers. So we've got to use yesterday's video. So check out the previous video in my playlist, in my exponential and logarithms playlist, or in my pure maths full syllabus playlist. That it's the previous video to this video. Because that's going to be helpful. So remember in yesterday's video that we said that 3 to the power of x is exactly the same as e to the power of x times ln 3. And remember that we said that 4 to the power of x is the same as e to the power of x times ln 4, using our conversions of base of some random base onto a base of e instead. So we're going to use that here. So we're going to convert these bases of 3 and 4 into a base of e, so they've got the same base. So that's what we're going to do here. So we're going to rewrite this 3 here, and we're going to rewrite it as e to the power of ln 3. So remember, the number 3 is just the same as e to the power of ln 3. Because again, the exponential and the natural log functions are inverses, and this is all to the power of 2x minus 7. And then the number 4, remember the number 4 is exactly the same as e to the power of ln 4. I mean, you can check this on your calculator if you like. E to the power of ln 4 is just 4. E to the power of ln 3 is 3. E to the e to the power of ln anything you like is that anything you like. And then we're just going to raise this all to the power of 5 minus x there. So then now we can kind of just use our laws of indices and expand the brackets. So we get e to the power of ln 3 times by 2x minus 7 is equal to e to the power of ln 4 times by 5 minus x. Okay, so now this makes life a little bit easier because now we've got base numbers on both sides of our equation which are exactly the same. So if we've got an equation, if we've got this equality here, we've got a number there the same as the number there, it must mean your powers there and there must be the same as well, because otherwise, like, they wouldn't be the same. So therefore, that means that ln of 3, so I'll do this in black ink. Sorry, let me do this here. So it means that ln of 3 times by 2x minus 7 is equal to ln of 4 times by 5 minus x. So it's just really a case of solving this equation and seeing what you get. So we can just expand the brackets here. So we get, so 2 ln 3 lots of x take away 7 ln 3 is equal to, expanding the brackets there and there, ln, well, 5 ln 4, I write it like this instead, 5 ln 4 take away ln 4 of x. So you just want to make x subject to the formula. So we can do this just by adding the ln 4x to both sides and take away this 7 ln 3. So if we do that, we get 2 ln 3x plus ln 4x is equal to 5 ln 4. Take away, plus 7 ln 3 just by adding that to both sides of that. Okay, so we get that there. And then lastly, what we can do, just by moving this all up. So lastly, what we can do is just factorize out the x. We get x times 2 ln 3 plus ln 4 is equal to 5 ln 4 plus 7 ln 3. And then we can divide both sides by this result there. We get x equals 5 ln 4 plus 7 ln 3, all divided by 2 ln 3 plus ln 4. And that would be your answer there. I mean, we haven't looked at the laws of logarithms yet, and there are some rules, just like the laws of indices and the rules of how we simplify simplify indices. There are some rules of how we can simplify logs. So we can actually simplify this fraction there, but because we haven't done the laws of logarithms yet, I'm not going to do that here. But obviously, you can just put this in your calculator and see what number you get to a certain number of significant figures. But if you had to write this in an exact answer, you can actually simplify this here. I mean, if you've already seen your laws of logarithms, I mean, I'll quickly do that now, actually, in case you have seen the laws of logarithms before. But if you haven't, do stay tuned for tomorrow's video, because that's when we're going to look at the laws of logarithms in tomorrow's video. But using your laws of logarithms, so I'll just do this in blue ink instead. So using laws of logs, you can actually write this result here as ln 4 to the power 5 plus ln 3 to the power 7 divided by ln 3 to the power 2 plus ln 4. And then what you can do is actually, what we will see tomorrow, again, we'll go through this properly tomorrow, is that when you actually add logs, you multiply the insides of the logs. So you actually get this ln to the power 4, a 4 to the power 5 times by 3 to the power 7 divided by ln of 3 to the power 2, which is just 9. I'll just write this as 9 instead, and then times by 4 there. So yeah, you'll get, I mean, I can't do these two big numbers in my head. I haven't got a calculator nearby, actually. So 4 to the power 5 times by 3 to the power 7, all divided by ln of 36. So, I mean, yeah, that would be your exact answer there in simplified form, if you know your laws of logs. But obviously, if you've not seen your laws of logs yet, don't worry about that, because we're going to do that in tomorrow's video. And we're going to explain why what I've done here is correct. But yeah, today's video was just really a summary of how we can actually solve exponential equations, both by applying logs of base of the base of what we got there, for example, and also equations where we've got different bases on both sides, and we can convert the bases into a base of e, and then we can use our knowledge of solving equations just to get the x value from there. So yeah, that concludes today's video.